Hello and welcome to our new unit on polar coordinates. This is going to be kind of a flashback into the unit circle because we're going to be using it a lot, and you'll see why in just a second. Polar coordinates are very different than your rectangular coordinates, which you probably haven't heard of and called it that before, but it's pretty much rectangular coordinates is everything you see here on the far left. We have an XY plane where we measure things. If I, for instance, measured out 1, -1, we would go 1 to the right, down 1. Or if we did, for instance, -3, 2, we go 3 to the left, 2 up. And that's what a rectangular coordinate is. It's just a coordinate where we have x and y. Okay? Now, polar coordinates are very different. And if you think of the word polar, hopefully you think of like polarity or like the North Pole, South Pole. And things that are polar are actually measured circular, okay? Or elliptical. So instead of having rectangular coordinates, we have things measured in circles, okay? So this is very different than our typical way of thinking in rectangular coordinates because we want to think in radiuses, radii, and radians. So if we have this, here's your rectangular, just so we're clear, rectangular coordinate system. So this is what we're used to seeing. And then now we're stepping into the polar coordinate system. The polar coordinate system still uses numeric values, but it also has radian values. So if I put a polar coordinate down, so the polar coordinate system, we would also label this 1, 2, and 3, and this point here is what we call our polar axis. This is our starting point. And if you remember from when we did the unit circle, we would always measure. For instance, if we did 90 degrees, we would measure 90 degrees starting at that axis. If we did, 270 degrees, we would wrap all the way around, okay? Or 3 pi over 2, however you want to call it. So that's our polar axis. That's our starting point, okay? So if I gave a coordinate, it's always going to follow this format. The polar coordinate goes r, theta. So what this means is this. If I put a coordinate here, let's call this 1, pi over 4. We could plot this point by by finding where 1 is. We know where 1 is, so that's the radius of the circle. And pi over 4, where does pi over 4 land in our unit circle? Pi over 4 is root 2 over 2, and it should land here. Because if you remember, we're thinking of this in terms of radians. Radians, wrapping around the unit circle, lands right there at that 45 angle mark. Okay, so we could call this plot point A. I'm going to put an A next to this. If for instance, we did a different coordinate, let's call this B. Let's put this in blue. Let's say we're going to do coordinate 2, and let's go 4 pi over 3. Now, if you remember where 4 pi over 3 is, awesome. If you don't, that's okay. We're going to go to 2 first, so we're going to be on, this is the radius of that circle, so we're going to wrap all the way around, but we're going to try to find where 4 pi over 3 is. 4 pi over 3 is right about here. So we're going to label that, we're going to plot that there, and we're going to call this B. So that's how we would navigate this polar coordinate system. The first value is always going to be pretty much a whole number or some numeric value. Then the second number is going to be in a measure in radians. So this is pretty much like a terminal side. So whenever we do this, think of this as like a radius, and think of this as radians or terminal side. Terminal side. Okay? So that is how we are going to navigate through this polar coordinate system. So let's practice some more. Let's get some quick rundown. We already did this first one, ironically, 1 pi over 4, and we would plot that and find where pi over 1 is first and foremost. We wrap around to where pi over 4 is, and this is our plot A. Okay, so for B, I'm going to do blue. So let's call this. Let's do, so -1 pi over 4 is a little bit different because if you notice, these are all radius of 1. Okay, so something very different about this is that this is not necessarily the negative. It can be, but it's not necessarily. This -1 pi comma pi over 4 is actually the opposite of 1 pi over 4. So it still has a radius of 1. What we're going to do is we're going to actually go to where this coordinate is and go in the opposite direction. So this is the opposite, because of the -1, of 1 comma pi over 4. So if you're looking closely, 1 going directly across with a radius of 1 will be right here, and this is B. So if you do have a negative value there, that's perfectly fine. Don't freak out. It's just if you want to think of it this way, I personally would. It's a little bit easier. It's the opposite direction of that particular coordinate. Okay? So, letter C. Let's use green. 2 comma pi, 4 pi over 3. And I think we did that. Wow, I keep repeating it. So 2 is here. It's non-negative, so we're going to keep it true to its true radian. 4 pi over 3, like we mentioned, is right down here. And we plot it. This is C. And then D, -3 comma 11 pi over 12. If you notice, actually, now in a unit circle, typically we only had denominators of 6, 4, and 3, and 2, technically, and whole numbers. Now we're including an extra pretty much radian or angle measure, if you will. These denominators of 12 are pretty much your 15 measures of 15 degrees. Okay, and that's actually very useful because if you really, really think about it, when we did this, we went 30 degrees, then 45, then 60, then 90. We actually skipped over those values. 75 and 15 are actually very, very useful because now all of these are evenly distributed through. Plus 15, plus 15, plus 15, all the way around the unit circle, and it's evenly distributed. So if you have something over 12, that just means we're working with the 15-degree markers. Okay? Or we're between, let's say, a 30 and a 60, or a 90 and a 90 and a 120. So in purple, -3 comma 11 pi over 2. So what I'm going to do is I'm going to look for 3 11 pi over 2, or 12, I'm sorry. So on our coordinate system, 3 is on the right here. 11 pi over 2 wraps all the way around here. And we're going to look for the opposite side. So I'm going to go all the way across, and this is where we land. That is the true value of what that coordinate is telling us to do. So I'm going to put a D here, and I'm going to erase that. And now we have our plotted point D. Okay, so that is how you navigate with the polar coordinates. Now, if we wanted to find multiple representations of the polar coordinate system, then we should, we should do something along the lines of part D. So let's draw a really, really rough sketch of the polar coordinate system. Okay, we want multiple iterations of 3 comma 5 pi over 6. So I'm going to draw a quick circle here. 1, 2, 3. Okay, so 3 is on this outer rim. 5 pi over 6, hopefully you remember, is pretty much right about here. It's almost a full pi, and that's our coordinate that we want to mirror. Okay, we want to have multiple iterations of this. So we can't have the exact same coordinate, but if you remember, we could actually do this. We could wrap all the way around again, and land on a different radian. So if you know you could add 2 pi, sorry for the bell, then you could say, okay, well, we know this is 3 comma 5 pi over 6. Let's take this 5 pi over 6 and add 2 pi to it, because we're going to add a full circle around, because that would land in the same spot. It's kind of like Earth, where it's the third planet. We're in this exact position. A whole year goes by and we land in the same position. So if we add 2 pi to this position, we could find a same coordinate. So let's do it. So adding 2 pi is the same thing as, pretty much we need the same like denominator, so I'm going to do 12 over 6, because that's the same thing as 2 pi over 1. And now we just add these. 5 pi plus 12 pi is 17 pi. Denominator stays the same, and then we could keep this as our first iteration. The radius is still going to be 3. And we're going to have 17 pi over 6. Okay? Now, we can obviously repeat this process over and over and over and keep adding plus 2 pi to this. And then we could get more versions of it. Ultimately, that's kind of boring, though. So we could also do this. We could go directly across, like how we did in these examples, and find a different version of it. So if you really look at this, we could call this -3, because we're looking for the opposite of that direction of that particular coordinate. So what is this distance then? Well, since this is a half circle, we could say, what is 5 pi over 6 plus 1 pi? Well, 1 pi over 1 is the same thing as saying 6 pi over 6. So 5 pi over 6 plus 6 pi over 6 is equal to 11 pi over 6. So this is our alternate coordinate. If we do 3 comma 11 pi over 6, remember the negative coordinate, the -3 here, means that we are taking this value going in the opposite direction. And we will land on that exact spot. Okay? So our second iteration of this would be -3 comma 11 pi over 6. Okay? And then lastly, we could actually use negative radians. So I'm going to erase that one, just so I could illustrate this clearer. If we wanted to go negative radians, if we wanted to go clockwise instead of normally we go clockwise or counterclockwise. If we wanted to go counterclockwise or clockwise this time, sorry, it's a lot of mixing that up. If we want to go clockwise this time, we could actually say that this 5 pi over 6 is the same thing as well, let's do this really quick. 12, this is 7 pi over 6. So we could call that -7 pi over 6. So if we wanted to, we could call this the third version of this. It's still a radius of 3, because if we want to land on the exact same spot, but if we want to call this -7 pi over 6, we would land on that exact same spot. Okay? So that is a third different way to do this. There's a million different ways to do this. There are actually infinite ways to do this, but these are just kind of newer, fresher ways to think about rotating around the polar coordinate system, especially when you go directly across and then use the negative version of that particular polar coordinate. We could use that too now. So that's added to our repertoire. All right. If you do have any questions, we'll definitely get a lot of practice with this, but if you do have any questions, please let me know, and I'll see you in the next one.